In this video, we're going to look at Le Chatelier's principle in which we have a concentration stress, except this time we're going to be graphing the concentration stress and examining how graphs change and how concentration stresses are presented on graphs. We're going to look at two concentration stresses on a graph to see what that will look like on a graph and how we can use the shift that we see to predict things about the reaction. So far we have our equilibrium system, so nitrogen and hydrogen in equilibrium with ammonia. Nitrogen is the purple line here, hydrogen is the green line here, and ammonia is the blue line here. If we look at the magnitude of change, we see that hydrogen has a change 3 times bigger than that of nitrogen, owing to their coefficients, and nitrogen has a change half of that of ammonia, again because of their coefficients. So the first stress we're going to look at, I'm just going to put a dotted line down where the stress will occur. So our first stress is going to be adding nitrogen into this system. So we're going to inject nitrogen into the system and we'll see the concentration of nitrogen instantly shoot up. The concentration of the other species, hydrogen and ammonia, don't instantly change. So we add nitrogen, we see its concentration instantly go up, and then because the reaction will shift to the right, away from the added nitrogen, we'll see the concentration of nitrogen go back down. So the concentration of nitrogen will decrease to a new equilibrium position. Because hydrogen is also a reactant, its concentration will also decrease. So the concentration of hydrogen drops with the same stoichiometric ratio applying, so still 3 times as much as that of nitrogen. And because we're shifting to the right, the concentration of ammonia is going to go up. And so our concentration of ammonia will increase after our stress. So where we've added the N2, that is our stress. After we've added the N2 is our shift, and then the reestablishment of a new equilibrium. The value of K won't change from the first equilibrium to the second because we haven't changed the temperature. We can look now at what happens when we remove one of our chemical species from equilibrium. So we are going to look at what happens when we remove nitrogen this time. So previously we added nitrogen. Now we're going to remove it. And we see a sharp drop in the concentration of nitrogen at the time the stress is applied. Because we've removed a reactant, our reaction will shift to the left to replace the reactant that we removed. So the concentration of nitrogen is going to go up. Because hydrogen is also a reactant, we'll shift towards hydrogen as well, and the concentration of hydrogen will also go up. Because we're shifting to the left, away from ammonia, the concentration of ammonia will go down. So once again, we have our stress, the moment that the system was changed, and then we have our shift in response to the stress, and the establishment of equilibrium again. So our first shift is a shift right, because it's shifting away from our reactants towards our products. Our second shift is a shift left, away from our products towards our reactants.